Hey guys, welcome back once again. This is Shrikant Rathod here, your virtual trainer. Thank you so much for the suggestion and the support on my previous video. So today's topic, what we're gonna discuss here is the fractions and decimals. These are the content of the today's class. So let's start up with. A fraction represents a part of a whole number. If I say, let's take P by Q, if I am representing, provided the condition is Q is not equal to 0, because any number divided by 0 is undefined. So P by Q, we say expressing a fraction. The P, this is called the numerator, and the down part, it's called the denominator. Okay, so let me just use the notation for the numerator as n and the denominator here as d. So it means, like, if I'm representing something, let's take, it has like 3 parts, and if I'm representing example, if I'm saying you 2/3, means I'm talking about the 2 part out of total 3. So this is the way of expressing the fractions based on the values of the numerator and the denominators, whichever the numerator is smaller or the greater, or the denominator is smaller or the greater, and other on, the fractions has been divided into 3 different categories. The first type of fraction, we say it's a proper fraction. Which type of fractions we can say a proper fraction? A fraction whose numerator is smaller than the denominator, or I can also say the fractions whose denominator is greater than the numerator. So example, I say 2/3. Yes, the numerator is 2 and the denominator is 3. So this type of fractions are called a proper fraction. Now, what do you mean by improper fractions now? The opposite of the proper. Fractions whose numerators are greater than the denominator. Such fractions are called improper fractions. So example, I can say 3 by 2, isn't it? So numerator is 3 here and the denominator here is 2. So this type of fractions we say improper fractions. There is another category also, that's we say the mixed fraction. A mixed fraction is the way of representing whole number along with a fraction. So if I say 2/3, isn't it? So 2 is representing a whole number here and 2/3 is a fractional part. This can also be written as 2 plus 2/3. So we can convert this mixed fraction into, whenever you convert a mixed fraction, always it will be converted into improper fraction only. So this is how we can convert here. There are, like, I can, instead of writing in this way, I can just multiply 2 times 3. What is result we are getting? 6. 6 plus 2. So whatever the numerator here, that we can do here as 2 times 3, 6 plus 2. The denominator remains as it is, 3. So I can say 8 by 3. Or if you are adding it, so whenever we add the fractions, we have to make the common denominator and we have to add the numerator. So same, that's what we're going to discuss in further, right? This is how you convert a mixed fraction into an improper fractions. Alright, so let's move next. For the competitive exams, it's important to know, like, the addition and the subtraction of the fractions. Sometimes they do ask the comparison of the fraction. So which fractional part is greater or which fractional part is smaller. So in all the cases, whenever you add or subtract the fractions, or whenever you are comparing the fractions, remember one thing, try to make their denominator to be same. If the denominator of the fractions, all the number which has been represented is same, then definitely you just compare the numerators, and based on the whether numerator is greater or smaller, you can arrange the number which are the smaller or the bigger, and so on. And while adding or subtraction also, make the denominator to be common and then just do the addition and the subtraction of the numerator only based on the number sign present in between. Now let me take one example here for the addition and the subtraction. If I take an example, let's take, says 3/4 plus 2/3 plus 1 by 2. These all are the fractions. So as I told, whenever we add a fraction, the first thing is we have to make a denominator to be same, or we say a common denominator. How you can make a common denominator here? So you have to find the least common multiple of the denominator, that is 2, 3 and 4. So what is the least common multiple? I'm going to explain in detail, but as I will be going to do as per this question only. So try to divide by the number. So first always try to divide by the 2, then if it is not divisible with 3, then it is not divisible with 3, then go with the 5. I mean to say, like, try to divide by the prime numbers. Now look at, when you are dividing these all numbers by 2, so this number and this number can get divisible, but 3 can't. So no, 2 divided by 2, it gives me 1. Whichever the number you can't divide, keep it as it is. And the 4 divided by 2, so it gives me 2. Let's say 4 divided by 2, I'm getting it as 2. Now the number whichever we got here are not multiple of each other, so stop here itself. So then your least common multiple here is multiply all the number with which you have divided and number which has been left, which are not multiple of each other. Okay, so if let's say example at the place of 3 we would have like 8, then I have to do the further division, because if there are number multiples, so we have to do the further division. Thing is, we have to make the number at the end which are not multiple of each other, and then product of all the number with which you have multiplied and the number which has been left, that's basically the least common multiple. So in our case, 2 times 3 times 2, so what we are getting here, 6 times 2 is going to be 12. So 12 is the common number, because the 12 is the number which appears in the 4 times table, 3 times table, and also in the 2 times table. So in this way also you can. So if you don't want to do all this is just I'm just showing, but it is not necessarily to do. So if you are like very good with the counting and also, think about a number which comes in like 2 times, 3 and 4 times table. That number itself is the common. The first number which appear, it is the common. So I have to make a common denominator to be 12 here. So here already here it has 4. With what number should I multiply to make the common denominator? Here is 12, so you have to multiply this by 3. So if you are multiplying the numerator, you have to multiply to the denominator also. I have the denominator here as 3. With what number should I multiply to make the denominator as 12? So I have to multiply by 4. So multiply 4 in the numerator as well. So I have 2. 2 times what gives you 12? So 2 times 6 gives us 12, right? So next, then do 3 times 3, so multiply the numerators, plus, okay, so denominator here is 12, plus 2 times 4 is 8, denominator here is 12, plus 1 times 6 is 6, denominator is 12. So this is how we make a common denominator, and this in general you can write it as 12 as a common denominator, and you can express it as 9 plus 8 plus 6, right? So 9 plus 8, what do we got? 17. 17 plus 6 is 23. So 23 by 12 is the result of the fraction which has been given. Okay, this is the way of adding. So no matter how big the numbers are, only thing is we have to make a common denominator and we have to add the numerator, that's it. Now as I told you one thing, like sometime you may expect a question based on the comparing this. Now it's like example, let me take the same example here, a 3/4 and second comes is like the 2/3 and the third one is gonna be half. Question here is which, arrange them in a order. Arrange them in a order from the smallest to largest. And we already say like which one is the smallest now here. 6 by whichever the number numerator is smaller, that is going to be the smaller. So 6 by 12 is the smaller. So 6 by 12 is basically the first term, right? So I can say 6, let me just write 6 by 12, then second comes here as 8 by 12 and the third comes here as 9 by 12. After writing this one, you can reduce it into their original form. So 6 by 12 can be written as here half, then it comes like 2/3, then it comes as like 3/4, right? So you have to arrange in this way the comparison or the arranging the number in order. You have to make the common denominator, then compare just the numerator, right? Right. Okay. Let me take another example relating with this. Example 2. If I have a number 2/5 minus 3/6 plus 2/3. Again, so as I have to make a common denominator, so which is the number appear in the 5 times table, 6 times table and 3 times table, which is the first common number, that's called the least common multiple. So I can do it in this way, 3, 6 and 5. So divide by 3, because 3 and 6 are getting divisible. 3 divided by 3 is 1, 6 divided by 3 is 2 and the 5 as it is. Just multiply them. 3 times 2 is 6, 6 times 5 is gonna be 30. So least common multiple here is 2 times 3 times 5, that is 30, right? So you have to make a common denominator to be 30 here. So with what number should you multiply 5 to make it as 30? Multiply it by 6. So multiply numerator also 6. Multiply 6 by 5 to make it as 30. Numerator also 5. Multiply here it by 10. So here denominator is also by 10. So now next it's gonna be 6 times 2. 12 by 30 minus 3 times 5. 15 by 30 plus, I'm taking the sign as it is, 20 by 30. Isn't it? So this is what we, so now let me just erase the some part of this side. Let me just erase this one, okay? Okay, as we already know that LCM we got it as 30 and this is the similar way. Alright. Now what is the common denominator we are getting? The common denominator here is 30 for all. So now we have to do it like 12, it's minus 15. So I can write it as 12 minus 15 plus 20. So BODMAS, or it's just add and subtract, you can do it in any order, but I am gonna show it in this way. You have to add first and then you have to minus. So 12 plus 20, it's gonna be 32. 32 minus 15 by 30 I am getting. So 32 minus 15, we get it like 17 by 30 is your answer, right? So this fraction is equivalent to 17 by 30 after doing the addition or a subtraction based on the whatever the sign in between, right? So no matter whichever the type of questions or how big the numbers here are, you have to make a common denominator whenever you perform add or subtract operations. Now let's move to the next. Let's see multiplication and the division of fractions. So this is the most simplest. So whenever you do a multiplication or the division of a fraction, let's take an example. Let's first discuss about the multiplication. Multiplication of a fraction. Let's suppose I have a 2 or more fractions here which has been written in the form a by b multiplied with c by d and so on. I'm just taking a simple example. So a by b is a one fraction, c by d is another fraction here. Now when they are telling you to do a multiplication, simply you can multiply numerator with numerator and denominator with denominator. Then I can say AC divided by BD. That's it, right? But before multiplying, if it's possible for you to reduce, so simplify further, you can simplify it. If it is not, just multiply numerator with numerator and the denominator with denominator. So it's very important to know, like, it's very important to know, if I'm writing example, let's take, if I'm writing an example, 2x times 3y times 4z. 2x times 3y times 4z, this is considered to be a single term, isn't it? So this is the single term with 3 variables. single term with three variables. So what I can say here, because whenever you are any number which is appearing in the multiple or the division form, that entire number or that entire term is considered, no matters how many variables or the number in that, you have to multiply them, so that when you do the multiplication you're gonna get the single result. That is what it is. 2x times 3y, or let me just represent the times here with this better. It's a multiplication sign. Okay, 2x times 3y times 4z. So just multiply number with number. 2 times 3 is 6. 6 times 4, what do we get? 24. So I can write this expression as 24xyz. That's why I'm saying this is a single term. But if there is an plus or minus sign in between, you can't do this, isn't it? If I say 2x plus 3y minus 4z. So these are three terms with three variables, right? With three variables. So what I can conclude, if there is a plus or minus sign in between, so that counts like the how many terms are there, it means it separates the terms. But if it's a multiplication or division, that entire expression is considered to be a single expression or the single term, right? That's what we are doing here. All right, so it's better to know, like, as though it's very basic, but it's better to know. So just recall your concepts. All right, let me take one example for the multiplication. If I say an example here, let's take, I can say here as 2/3 times, let's take 9 by 5. I'm multiplying the two fraction, that is 2/3 times 9 by 5. So as I told, so you can just do the multiply the numerator with numerator and the denominator with denominator. But before multiplication, you can simplify it. So look, it's not necessary that 3 has to divide only the 2 or the number here. 3 can also divide the other terms which is appearing, as this is the multiplication, or we can say the entire term is this 1, right? So what I can do here is, I can do 3 times 1, 3 times 3. So what then, is there anything to be simplified further? No, because 2, 3 and what is left in the denominator here is 5. They are not at all multiple of each other. So now just multiply numerator with numerator and the denominator with denominator. 2 times 3, what we get here as 6. 1 times 5, we get it as 5. So this is the equivalent result for the multiplying. If it is further possible to simplify, simplify. If not, keep it as it is. Okay, I can also do in this one. 2 times 9, it's 18. 18 over 15, it's equivalent to 6 by 5. That's it. Now let's talk about the division. Division of fractions. Division of fractions. Division we can represent in a different way. Now let me just take one example. If I am saying A by B divided C by D, this can also be expressed as A by B divided with C by D, right? So this is the different notations what we can use. So whenever you are doing the division, division of a fraction, so remember one thing, keep the first term as it is, A by B, and this division sign can be converted into multiplication by flipping the second term. So whatever the second term here, that is C by D, so you can convert this division into multiplication by flipping. So C by D can be written as D by C now. So then follow the multiplication rule. So multiply numerator with denominator, or before that you can simplify and then multiply. All right, let me just take one example here to demonstrate. Example, let's take 3 by 4 divided by 2 by 5. This can also be written as 3 by 4 divided with 2 by 5. Alright, so as I told, keep the first term as it is, 3 by 4 as it is. The division can be converted into multiplication by flipping the second term. So 2 by 5, now I can write it as 5 by 2, isn't it? So after that, if it is possible to simplify, simplify it. If it is not, keep it as it is. So no, because I can't cancel the 3 or 5 with the 2 or 4. Remember, you can't cancel the same denominator with denominator, okay? So denominator terms and the numerator terms. So you have to simplify the numerator with denominator. Don't cancel 2 times 1 and 2 times 2 as 4 here, because both 2 and 4 are appearing as the denominator. Alright, so there is no common term which refers to the numerator and denominator. Just multiply their power, just multiply them. 3 times 5 is 15 and 4 times 2 is 8. So this is equivalent to 15 by 8. After division, after division, doing the long division and all, whatever the value you're gonna get, that is like the division of the fractions equivalent result. Okay. Alright, let's move to the next part. That's the decimal. Yes, another common type of question you expect on the competitive exams is based on the decimals. So how do we represent a decimal number? So let me write an example. If I say 123.456 example. So any number in between point, such numbers are called decimal numbers, and the number before this are called the whole numbers or the complete numbers, and the number after the decimal point are called a fractional numbers. Okay, these are the decimal part, or I can say are the fractional numbers, or we can also say the decimal part. Now if I want to know, so what is the place values of each number, so let me start from this side. This number, it's called the ones place or units place. Unit or ones place. This number, we say it is at the tens place, and this number here, it is at the hundreds place. This is the place value. But when I'm going after the decimal part, the first term, this is called tens place. The tens meaning 1 by 10 times 4. Tens place. So 1 by 10 times 4, that gives me 0.4. If I'm just talking about the first, this is basically the 0.4, right? And this term, it's called hundredths place. Hundredths place. Not hundreds. Hundredths. Okay? Place. And this is basically 1 by 100 times the 5. That's 0.05, what we say. And this term, it's called thousands place. Thousands place, and so on. This is the number representation and the place value of the decimal numbers. Okay. So sometime they may expect you, they'll give you a decimal and they just want you to represent in the different representation. Let's take an example. If I say, if I have a number, let's take 0.00543, or let's say 0.00543. This can also be expressed in, so I can also be, this decimal is also equivalent to 5.43 into 10 to the power negative 3, right? So whenever I'm writing 10 to the power negative 3, or it means 5.43 divided by 10 to the power 3. This is also equivalent to 5.43 by 10 to the power 3. So that's same as 5.43 divided by 1000. So that gives you the original value as 0.00543. 543, right? So this is just an equivalent way I'm representing. So this number is also equivalent to this. In a competitive exams, they give you a kind of question and they ask us which of the following is equivalent to the given decimal. So this is gonna help you to solve those kind of questions. right? Let me take another example here. If I have a number something like 5 4 3 2 1, this can also be represented in the decimal. I can write it here as 5.4321 into 10 to the power 4. Now look at after decimal point how many? 1 2 3 4. So I have put the decimal point after 4 digits, so you have to do 10 to the power 4. And here I put a decimal point after the 3 digits. Here I'm counting right, okay, but here I'm going left. From here I'm going 1 here, 2 3 and 4. So whenever you are counting from the right to left, you have to put 10 to the power the how many digits you are shifting, and when you are going from left to right, you have to do 10 to the power minus of that many digits which you passed, right? So this is also equivalent to this, just a notation, right? And another example here, if I have a number 0.30000 something, so this 0 doesn't have any value, doesn't have any value. It means I can say 0.30000 is just equivalent to 0.3. They don't have any value. But if I have any number something like 0.0003, yes, these zeros carry some values, because after the zeros, if there is some number, so then there is a values for the zero. But after some number, after the decimal point and after some number, if the no matters how many times the zeros are repeating, they doesn't carry any value. Okay, let's move next. Other important part of this one is the converting decimal to a fraction. So this is the most simplest. Whenever they say to convert the decimal to a fraction, so this is what we're gonna do. If I have an example, 2.34. While converting decimal to fraction, what I need to do is write the number as it is without the decimal part. So 2.34 can be written as 234. After that, write 1 always, and then count after decimal point how many digits were there. After decimal point there are 2 digits, then I'll be writing it as 2 zeros, right? So 234 divided by 100, or you can further simplify it. So this is how you represent a decimal to a fraction conversion. Let me take another example. If I have this one decimal 0.0012, I can just write as a number without a decimal point, 00012, just as 00012. It's same simply as like 12 divided by, after decimal we have to write 1 as it is. After decimal point how many digits were there? Count 1 2 3 4. There are like total 4, 4 numbers. So I have to write 4 0 0 1 2 3 4. So 12 divided by 10,000 is the equivalent fractions to the 0.0012. All right. Okay. Now let's move to the next. Converting fraction to a decimal. Yeah. So this is a little different from what we did previously. Whenever you go for converting fractions to the decimal, you have to do a long division. Long division. What does it mean? Let me take one example. I have a number. Convert a 25 by 4 to a decimal. They are saying 25 by 4 is equivalent to what in decimal. So what we have to do is, we have to do the long division of this number. Whichever the number at the top, that is the numerator, will go in, and the number which here we are dividing, that will be outside. And this is called the dividend. The 4, the number with which we are dividing, is called the divisor. And let's now how do we do the long division? Here is, you have to count, or you have to read the 4 times table. and you have to reach to the number equal or lesser than the 25, but you should not exceed. So 4 times what gives you the number which is very much near to 25 or equal to 25. So 4 times, let me just say 4 times 6, 4 times 6 gives you 24, correct? So 4 times 6 is 24. I can't exceed. 4 times 7 it's gonna be 28, so I should not cross that 25. So I'm just taking it like 4 times 6. Then you have to minus it. So 25 minus 24, what we get? 1, right? So now look at, still there is some part has been left, but now look, whatever this is called the remainder, whatever the remainder we got, this number is smaller than the divisor. So if whenever the remainder or the number smaller than the divisor, you have to put a point here and you have to take a 0 after putting the point. You can add this number with a 0. Now it becomes 10. 4 times 2 is 8. Again I will be repeating the same steps. 10 minus 8 is 2. Now again it is smaller, and we already put a decimal point here, no need of putting it again. So you can take a 0 whenever needed. So 4 times 5, it's gonna be 20. So now just do 20 minus 20, it's 0, 0, right? This is basically the remainder, and this part it's called the quotient in the division. Of course, there is one topic called the functions and the remainder. So I'll be discussing all the properties and everything in that one in the topic called the remainder. So as of now, let's just remember this itself. Okay. So I can say 25 by 4 is equivalent to 6.25 in the decimal representation. So that is how we convert fractions to a decimal. This is the common way. No matter whichever the question, if they're expecting you to do, so you have to convert in this way, right? Now, another type, converting a recurring decimals to a fraction. Now, what do you mean by recurring? So, recurring, it means the repeating decimals. Recurring decimals, it means the repeating decimals. So, if I write some example, let's take. If I write some example, I can say 0.123, 123, 123 and so on. Look at here, 123 is repeating till infinity. The same digit like 123, 123, 123, they are repeating with the infinity, and these are called the repeating decimals. And the repeating decimals, there are different ways to represent them. So 0.123, instead of representing till infinity, this can be written as 0.123 bar. This bar representing that 123 is repeating, or this can also be written as 0. in the bracket 123. These are the different notations. So you may get it in this way in exam, or in this with a bar, or something written in the bracket. It means that those are the recurring decimals or the repeating decimals. So now sometime a question will be to convert a repeating decimals to the fraction. So I can't do the same way like how we were doing before, because I don't know, the numbers are getting till infinity. I don't know how many integers are there. So that's the reason I don't know with how many zeros should I write at the denominator. So there is some ways to convert the recurring decimal. So let me just explain the example how it works, and then I'll follow the shortcuts, right? Let me take one example here. I want to convert a 0.3333 to a decimal. Okay, my question is convert a 0.3333 to the decimal. So this is how it works. So now what I need to do is, whatever the number you're supposed to convert, assign it as x, that is 0.3333, it goes till infinity. After decimal point, check it how many digits are repeating. Only one digit, that is 3, is repeating. If only one digit is repeating, you have to multiply this expression by 10. If the 2 digits are repeating, you have to multiply that expression by 2. And if 3 digits are repeating, you have to multiply that expression by 3, and so on. In this case, 3 digits are repeating here, you can multiply that by 1000, isn't it? So 1 digit repeating times by 10, 2 digits repeating times by 100, 3 digits repeating times by 1000, and so on. Okay, so now as I told, so we have to times this by, let me consider this is the 1, expression 1. Now what I do, multiply expression 1 by 10, because after the decimal point 1 digit is repeating, then your expression becomes 10x is equals to, isn't it, 10x is equals to 3.3333 is goes till infinity. Let me consider this is the second part. Now what I do, then do second minus the first, whatever answer we got here, second part minus the first, it is got as 10x minus x is, I can write as 3.3333 infinity minus 0.3333, right? So 10x minus x, what we get here, 9x is equivalent to, now look at, of whatever the digits after the decimal, they all get cancelled out, 0.33333, and that is, you know, just subtracted. So I just left here is 3 minus 0, that's why I get it as 3. So 9x by 9x is equals to 3. From this one I can say x is equals to 3 by 9, or I can say 1/3, right? This is the value. So this is your fractional number was 1/3, and that fractional number, if you are representing in the decimal form, that is equivalent to 0.33333, right? So that is how we convert a recurring decimal to a fractional number. Now this is the long method. If the numbers are bigger or the like many repeating terms, so it's gonna be lengthy, or it will take a long time to solve. So we need to follow the some rules or the shortcuts here whenever this kind of question appears in the quantitative exam. So remember, while converting, separate the recurring number. First step what I need to do here is, let me just take the same, okay, I'm talking about the example of converting the 0.3 into a fraction, 0.3333 into a fraction, or I can also represent 0.3 bar into a fraction, or I can also say 0.3 in a bracket. I want to convert this into a fraction. The first step what we need to follow is separate the recurring number from the decimal fraction or the decimal part, which is the recurring number 3. So my step 1 is separate which number is repeating, I mean to take down the number which are repeating, that is 3. The second one is annex the denominator with 9s as many times the length of the recurring number. As we know that only digit 3 is repeating, so I have to divide that number by 9. So then we say 3 by 9, I'm getting it as 1/3. This is the same as what we got here. So remember, if the 2 digits are repeating, then you have to divide those repeating number by 2 9s. If the 3 digits are repeating, you have to divide those numbers by 3 9s. First you take the whichever the numbers which are repeating, then they divide by 3 9s. Let me take the same example as we mentioned here. If I have another example saying that it says 0.123 and so on, or I can write 0.123 bar. It means after decimal point there are like 3 digits are repeating. So that how do we follow the shortcut? Take down this same number, that is 1 2 3, and we know that after the decimal point 3 digits are repeating, then you have to write the 3 9s, 1 2 3. So 0.123 this is equivalent to 123 over 999, that's 999 as the fractional equivalent. If it is possible to simplify further, yes, simplify. If it is not, keep it as it is. 123 and 999, yes, I believe it's further possible to simplify because it's go with the 3 times table. 3 times 4 is 12, 3 times 1 is 3, and 3 times 3, 3 times 3, 3 times 3. So this equivalent to 41 over 333. So if it is further possible to simplify, simplify it, or else that is equivalent to 41 over 333 is equivalent to this recurring decimal part. Alright. This is the, no matter which are the type of number or how big the number are, if you have to identify the what is the digits or the number and how many they are repeating after the decimal point. So this is the type of question. Now what if you have a decimal number with there are certain repeating number and the non-repeating number? You may also expect a question in this way. Okay, what if we have, let's take another example here. To convert a recurring decimal, or I can say to convert a mixed recurring decimal to a fraction. So if I take some example, the number they may have with the repetition and the number they may have a with the non-repetition terms as well. Now let's take an example here. Question says convert 0.25 12 to a fraction, because this decimal whichever I am representing with the mixed recurring, because 25 is not repeating, it's fixed, but 12 it is repeating till infinity. This is can be represented as equivalent as 0.25 in the bracket 12, or I can also write 0.25 12 bar. These are the different notations what we need to use. Okay, while converting this type of decimal to a fraction, what we need to do is, the first step what I need to follow is write down the number consisting the non-repeating digits and the repeating digits. So write down the numbers consisting of non-repeating and the repeating digits. So what I do, the step 1, I have to take down the number as it is, that is 0.25121212. I should not repeat the number, but I have to take the number as it is without repeating. Then I can take like 2512, right? These are the digits, different digits which are appeared in that one. And now the step 2 here is, what the step 2 should I do? Subtract the non-repeating number from the above. We have to subtract the non-repeating. Which are the non-repeating number we have? 25, isn't it? Subtract the non-repeating number from the number what we have written here. So then what I do here, so 2512 minus 25, I have to subtract the non-repeating part. So what we get after subtraction, so 12 minus 5 is 7, so 10 minus 2 8, and the 4 2, so we are getting it as 2487, right? So this is what we got. And the next step here is step 3, whatever the answer you got here, 2487 divided by, after the decimal point, if the two digits, how many digits are repeating, that many zeros we have to write. That's what we saw in the previous example. If 3 digits are repeating, how many zeros are repeating, that many nines I'll be writing at the denominator, right? If the 2 digits are repeating, I'll be writing 2 nines. If 3 digits are repeating, I'll be writing 3 nines, and so on. But here there are the some digits which are repeating and there are the some digits which are non-repeating. Then what should I do now? So in such case, what we have to do is, that's what we are doing, divide, this is, divide 1 by 2. So they are saying that divide 1 by, this is after subtraction, and after division, whatever the result I am getting here, divide that by the number of nines and the zeros. Divide, that is divide 1 minus 2 by the number of 9. This is my step 2. So number of nines and the zeros, for every digit write down 9, and for every non-repeating digits write down the zeros after. For every repeating digits I have to write a 9, and for every 9 non-repeating digits I have to write the zeros after the 9s. Now in our question, there were 2 digits were repeating, that is 1 2 1 2 1 2 and so on. So I'll be writing 2 nines, and there are 2 digits which are non-repeating, that is 2 5, right? So the digits which are not repeating, so we have to pad with the zeros after 9, and the digits which are repeating I have to write that many 9. So for the 2 5, which are 2 digits which are not repeating, then I'll be writing 2 zeros. Okay, so 2487 divided by 9900, this is an equivalent fraction of the decimal recurring with this 0.25121212. If it is possible to simplify it, or else keep it as it is. As the numbers which are multiple of 3, so what I can say, 3 times 8 is gonna be 24, 3 times 2 it's gonna be 6, 2 carry forwarded, 3 times 9 is gonna be 27. So 829 by 9 divided by 3, 300 as it is. So 3300. This is the equivalent fraction of the recurring decimal, right? So this is how you convert a number which, if we are there, sum of the part as the repeating and the sum of the part as the non-repeating. Okay. Again, you may think about, what if the decimal number which has like the whole part and also a decimal part with the repeating and the non-repeating. That is the third type. Now in that case, what we can do is better. Let me take one example. So it will be better for us to understand. Let me just take example. Oh, sorry, let me just change the color. Okay, example. If I say I have a number 2.1234, 2.12343434 and so on. So this number has like a whole number, a decimal number, fractional number, along with the repeating and the non-repeating. The one way I can tell you is this can also be written as 2 plus 0.123434 and so on, and you follow the same pattern what I told here. So what we can do here is you can solve, converting the repeating and the non-repeating decimal into a fraction, and whatever the result you are getting, you can add with the 2. That is the one way. Or other way we can follow with the the same way what we discussed. Always take down the numbers including the repeating and the non-repeating. So I can say 2, 1, 2, 3, 4, isn't it? So 2.1234. So this is the number. After taking the number including the whole, the decimal, repeating and non-repeating, my next step is I have to subtract the number which are not repeating, including the whole number. In our case, the 2.12, this number is not repeating, so I have to subtract it like 212. So when you subtract 212 with this, what is the result you're gonna get? 4 minus 2 is 2, 3 minus 1 it's gonna be 2, 2 minus 2 is 0, you are getting it as 1, 2. This is the number what you got, right? So this is equivalent to 21022. Now after doing this one, I have to follow the same step. For the number of zeros for the number of digits repeating, I have to write that many 9s at the denominator. So that is after the decimal point, the 2 digits are repeating, that is 3 and 4. So I have to write it as 2 9s. And after decimal point, the 2 digits which are not repeating, what are those? 1 and 2. So for that one, I have to write 2 zeros, 2 9s and the 2 zeros. But what about the whole number? Whenever there is a whole number appearing here, don't do anything. Don't add any 9s or the zeros at the end. Okay. So, but while subtracting, you have to consider that part. So I can say 2.12343434, it going to the infinity. This is equivalent to the number which we have represented here, 21022 divided by 9900. You can just check for your simplicity. If you do the long division with this, you'll be getting definitely the recurring part. Alright, or else you can separate the two and then you can follow the same approach what I explained in this example and then add 2 to that result. Definitely you're gonna get the same answer, right? These are the variety of question what you expect on converting recurring decimal to fractions. Okay, let's move next. Rounding the decimal. Rounding the decimal drops the extra decimal place. If the first dropped digit is 5 or greater, round up the last digit that you keep. If the first dropped digit is 4 or smaller, round down. So if my last number is the place number which I am talking about, if it is 5 or greater, we have to round it to the up. And if my last number here is or the place number which we are talking about is smaller than 5, we have to round down. I mean to say the keep the same, right? So let me take some example. So it is better with the example to make you understand. Let me take an example. I have a number 5.3485. Okay, I have a number 5.3485. Now question is round up to nearest tens. This question is round up or round up to nearest tens. Nearest tens. Now look at after the decimal point, which is the number which is the tens place. This is the place, right? So I have to write it like 5 point, only one digit should I write, that is the nearest tens. Now this is the what my tens number. You have to look the next number to that. If this number, if the next number or the next digit is less than 5, keep the number as it is. It means like, the 5.348 3485, we can round it to the nearest tenth as 5.3 itself, because we are not rounding it up or rounding it or adding it by 1, because if the next number is less than 5, then we have to keep this number as it is by ignoring the other part, that is equivalent to 5.3. Now let's take another example. Let's take 5.3485. Now if I say you round this number, round it to nearest thousands. Alright, sorry, let's take round it to the nearest, okay, no problem, thousands, okay, round it to the nearest thousand. So this is the tens place, this is the hundreds place, and this is the thousands place. So I have to look at this number as the reference. If the next number is greater than or equal to 5, I have to add 1 to this one. So my number nearest to 1000 is going to be 5.34. 1 plus 8, it's going to be 9. That is what we say the round up, right? So 5.3485 can be rounded to the 5.349 to the nearest 1000, right? So let's take another example. Why? Because my next number is 5, or if it is the next number is 5 or greater, I have to add 1. Now let's take another example. Same, let me 5.3485. Round to nearest hundreds. Okay, so nearest 100, so this is the tens and this is the 100. This is my positional number. If the next number is greater than or equal to 5, I have to add 1 to the existing one, so that is I have to do plus 1, right? So then the number nearest 100 is going to be 5.3. 4 plus 1 is going to be 5. So this is how you round it to the nearest tens, nearest hundreds, or nearest thousand, whatever the number they tell us to do, right? So this is the way of rounding. All right. Okay, that's it for the today's class. So guys, please share and subscribe to my channel and click on the bell icon so that you will be notified whenever we upload the new videos. So thank you so much for watching. Thank you.